Good day everyone. Before we start our lesson for today, I have here a scenario here in our presentation that would help us visualize our lesson for today. Okay, so please read everyone. Who one joins a barangay game. He wins if he picks a red ball from a box containing 5 red balls and 2 blue balls. The question is the game fair? Yes, probably one will say it is fair. The other one says it's not. How about this question? Does one have a high chance of winning? Probably yes, probably not. Okay, next question. How can we determine one's chance of winning without actually throwing a ball? What if there is no container? What if there is no box that contains a ball? Can we compute that one? Probably, okay. Some of you may say yes. Lastly, can mathematics help us measure up his chances? Yes, we can really, mathematics can truly help us in measuring his chances. So that will be our topic for this day, which is all about theoretical probability of a single event. So our learning for objectives for this meeting, that is to define theoretical probability of a single event, calculate the theoretical probability of a single event, show curiosity and perseverance in solving probability problems, and lastly, honesty and fairness in game and decision making. Alright, so I have here an activity that is pick and choose. So I will choose one student from this group and one student from this group. Alright, please come forward. So in this container, I have red papers and blue papers. So there are 4 red papers and 2 blue papers. And all you have to do, students, your participants, to pick a color from or pick a paper in our box and then record the color, and after that you return the paper in this box. You will repeat that one for about 10 times and count the number of total red draws and total blue draws. Okay, start. Okay, so from your activity, thank you so much everyone by the way. So from your activity, which color appeared more often? Okay, in this group, it appeared red. Okay, for this one, it is red as well. Okay, so what's the result? Always the same for every group. Okay, so in this group, she picked 4 reds. No, not 4, yes. 8 reds and 2 blues. And for this group, she picked 10 reds. Okay, so which color was expected for you to appear in our activity? Red? Okay, why? Because of red has more colors than the blue ones. Okay, so those are actually chances of a certain event. But why? Because the chances of an event depends on the number of favorable outcomes compared to the total number of possible outcomes. So let us define that one in our topic, which is the theoretical probability. Okay, anyone? Any idea of theoretical probability? Okay, so let us define theoretical probability. It is the likelihood that an event will occur based on all possible outcomes. So we can use the formula in getting the probability of an event is equal to number of favorable outcomes over the total number of possible outcomes. So in each event, you can identify its probability or its chance while using this formula. Okay, so a single event is one specific outcome that may happen in a probability experiment. So most of the time, when you just theorize the certain probability or certain experiment, you are using theoretical probability. Okay, so in probability, the probability is always between 0 and 1. That is always true. If it is closer to 0, then it is less likely to happen. If it's closer to 1, then it is more likely to happen. Say for example, we have here an example, rolling a die. You are going to find the probability of getting a 4. So how are we going to solve that one in our problem? So we have here the probability of an event is equal to the number of favorable outcomes over the number of total possible outcomes. Alright, so in our problem right here for number 1, we are to identify the sample space. What is the sample space in our problem? We have a die that has 6 faces, and each face has a certain number from 1, 2, 3, 4, 5, and 6. So that will be our sample space. How about the favorable outcome? Our favorable outcome is 4. Okay, so let us substitute the one in our problem or our formula. So we have the favorable outcomes. How many favorable outcomes are there? There is Okay, and answer the following problems. Your timer starts now. Alright, finalize your answers in 5, 4, 3, 2, 1. Okay, so I want you to present your answers on the board. Okay, and for this group, present your answer. Alright, let us listen everyone. Okay, a big round of applause for Group 1 presenters. Next, Group 2. Okay, a big round of applause for the Group 2. So let us check whether their answers is correct or not. Okay, so for number 1, you are to find the probability of drawing 2 of hearts. So how many hearts are there? There's just 13 hearts, but there is only one card that has 2 numbers. So therefore, the probability is 1/52. So both groups got the correct answer. Next, number 2. Find the probability that the day begins with letter S. So the answer for this one, is this correct? Yes, their answers are correct. The probability is equal to 2/7. Okay, how about number 3? What is the probability that the letter E is chosen from the word perseverance? How many letters are there in perseverance? There are 12 letters. How many E letters? There are 4 letters. So therefore, we substitute 1 and we reduce it to lowest terms, which is 1/3. So a big round of applause for Group 1 and Group 2 for having the correct answers for our activity. Alright, so question. Any questions or clarifications before we have our assessment? Okay, so no more questions. Please get 1 sheet of paper and answer the following questions. I will just give you 5 minutes. Your timer starts now. Alright, so finalize your answers in 5, 4, 3, 2, and 1. Okay, exchange your papers with your seatmates and write corrected back. Alright, let's check your answers. For number 1, what is the probability of getting an ace? Okay, so the answer is 1/13. So you check, 1 check for the formula, 2 checks for the final answer. Alright, next. The probability of getting a red card. What is the answer? Okay, the answer is 1/2. 1 check for the formula, 1 check for the final answer. Alright, number 3. A numbered card greater than 6. This one is a tricky question. So you will exclude those with faces and you just, from the possible outcomes, and then after that, you count the number of cards that has a number from 6 or greater than 6. Okay, so what will be the answer? The answer is 2/5. Okay, 1 point for the formula, 2 points for the final answer. And count the number of correct answers. The highest possible score is 9 plus 1 for your attendance. Alright, return your papers to the owner. Is there any questions or clarification with our topic? None so far? Okay, so for you to reinforce our lesson for today, I will give you an assignment to be submitted next meeting. So all you have to do is to interview a family member about the situation that involving a chance, may it be lotto, card games, or drawing plans. And after that, you write on your 1/4 sheet of paper the situation, the sample space, the event, and its theoretical probability if outcomes are equally likely. So question? None so far? Okay, so thank you so much for listening. I hope you learned something from me today. That's all for today. Goodbye, everyone.